let's see. Yeah, great video, right, Greta? All right, so chapter 4, we're on chapter 4, right? We did 4.1 and 4.3 in class on Monday, and today I want to go over 4.4. The chapter 3 test is due on Monday, so get that out of the way. Does anyone have any questions on chapter 3 test, the two sections in chapter 4? Oh no, Elijah. So Elijah says that he streamed his game for 50 people and was not sharing the game. Yep, pretty much that's what I was like. Just talking away about math with a picture of myself. Test was good. Well, Elijah, you can turn in 4.2 if you did that already. Mackenzie says she hasn't taken the test, so she'll let me know. Okay, so, well, if there's not any questions, let's go ahead and dive in so we can get you guys on your way for the rest of your Friday. All right, so the good news about 4.4 is that it's pretty much no different than 4.3, except instead of in 4.3, remember those last three, actually all the problems, we're talking about quadratic equations. So a quadratic equation means that we have a squared term, and it's in the form ax squared plus bx plus c. So in 4.3, we factored all of these quadratic equations, and then we figured out that we could solve them, right? So 4.4, the added twist is that we have the same quadratic equation, except that out in front of this squared term, we now have a number. So for example, the first one has 3n squared versus just n squared. So that's basically the whole difference between the two sections. So hopefully you remember how to factor with a term out front. If not, we're going to go over that. So let me do that now. So if you recall, what we're doing is we're factoring these equations or unfoiling. And the reason that we're trying to do this isn't just to, remember how to factor in math. The ultimate reason is that we want to be able to solve these types of quadratic equations. And one method for solving quadratic equations is by factoring them, right? So this is where I was saying, if you have a keyboard that works, if you have something times something equals 0, so this is our fancy factored format, right? Something times something equals 0. That means one of the two somethings has to be 0. Either this has to be 0 or this has to be 0 in order to get an answer of 0. Because you can't multiply like 1/2 times 2, you get 1. You can't multiply 1,000 times negative 1,000. I mean, there's no way to get 0 other than one of the two things that you're multiplying by has to be 0. So if we can factor these quadratic equations into this form, something times something equals 0, then we can say, well, the two answers are either the first factor is 0 or the second is 0. So that's the ultimate goal, right? Not just to torture you with factoring. All right, so let's practice with different color here. Let's practice with this first one. So we have 3n squared plus 7. This whiteboard is not my friend today. Plus 7n plus 4. So it's a little bit more tricky to factor something that has a number out front, because when we factor and there's not a number out in front of the squared term, we don't really have to worry about that squared term. Now we have to actually think about both the first and last term and how they relate to each other. Okay, so what I mean by that is we know when we factor, we're going to end up with these two factors, right? So that's good to go. When we're trying to figure out the last term, we do that by saying, okay, 4 is going to comprise our last term. So what are all the ways that we can make a positive 4? We can make a positive 4 using 1 times 4. We can do 2 times 2. We can also do -1 times -4. And we can also do -2 times -2. So all of these are all those years that in pre-algebra that you had to factor numbers. This is where it's coming back for you, right? So we have that to figure out, but we also have to think about our first term, which we really didn't have to think about in the last section, right? If we had n squared before, we would know in order to make n squared, we just do n times n. But we have 3n squared, so we have to think about how to make that. Well, there's actually only very few possibilities that do make a 3n squared, which are 3n times n to make 3n squared. All right, so then now we have to figure out, okay, I know that one of these is going to be 3n and one is going to be n. I've got that down. I have to figure out what combination of factors of 4 we're going to put into my last spots so that ultimately when I FOIL, my middle term ends up to be 7n. So there's a couple of ways you could do this. You can just flat out guess. Some people just like that method. So you can kind of say, I think it's going to be 2 and 2. Okay, so we already have in the FOIL, so we have to FOIL this, right? We already have the first and the last taken care of because that's what we did. So let's check the inside outside. So outside is going to be 6n and inside is going to be 2n. So I'm doing outside and inside, and that's going to give me 8n. So that's not going to work. So not 2 and 2. So let's go ahead and try. Oh man, thought I could go backwards. Let's try 3n plus 1 and n plus 4. All right, again, you can FOIL everything. You can do first and last, but because you've already looked at the factors up here, you're pretty sure their first and last should be right. So let's check the inside outside on this. So the outside is going to be 12n plus n, and that's going to give me 13n. That's way too big for 7n, right? 8n. Okay, so now let's try, just make a mess of the whole paper. 3n plus 4 and n plus 1. So also when you have a number out front, the order of your factors make a difference, right? So before you had 3n plus 1 and n plus 4, we've switched and put the plus 4 with the 3n and the 1 with the single n. So if we factor this, we get outside, inside, we get 3n plus 4n, which we get 7n. Bingo, that's what I'm looking for, is 7n, right? So in order to factor the first one, we can say that 3n squared plus 7n plus 4 can be factored as 3n plus 4 times n plus 1. Fun, right? Lots and lots of math. Funness. Now, did everybody follow along with that? I know I skipped a few steps with FOIL because I kind of assumed since we talked on Monday with FOIL and we talked about factoring that you had that covered. But if you need a little more explanation, you can let me know too. Everybody follow kind of all right? Why are you allowed to move the plus 4? Because that's a great question, Elijah. Because what we're actually trying to do, it's kind of like a puzzle, right? We're trying to figure out what combinations of numbers that we want that combine when they're multiplied together, give us the original quadratic equation. So as long as you're trying to get a plus 4 at the end, right? So you can get plus 4 at the end by multiplying 4 times 1, or you can get it by multiplying 1 times 4. It doesn't matter which way you multiply, 1 times 4 or 4 times 1, you're going to end up with a positive 4 at the end. So you could play with the equation a little bit to figure out which way the terms match up in order for you to get the middle term correct. Okay, let's tackle a couple more of these. I'm actually going to scroll here a little bit. Okay, so the second equation, remember how I told you that math people get really excited when they see perfect squares? I'm like, ooh, look at this. These are both perfect squares. 4 is the perfect square of 2, and 25 is the perfect square of 5. And there's no middle term, right? There's 4r squared, but there's no just regular r term. And then there's 25. So this one looks like one of those fun perfect square equations. At least I'm hoping that it's a perfect square because that's how I can cross off middle terms. Okay, so have the list handy of your perfect squares or memorize it or whatever you want to do. So what I mean by that is, okay, 4r squared, there's multiple ways to make this. I could make 4r squared by 4r times r, or I can make it by 2r times 2r. Those are my options. There's lots of different ways to make 25, right? 1 times 25, 5 times 5. Those are the big ones. Okay. Because I don't have any middle term, I want my inside-outside term to cancel each other out. I'm really rooting for the whole idea of a perfect square because that means that everything's going to be balanced and cancel each other out. So whenever you see something that looks kind of like this, think, can I use my perfect squares and cancel things out? So before we mess with all this other stuff, let's go straight to the perfect squares. So what I mean by that is 4r squared can be made up of 2r times 2r, and 25 can be made up of 5 times 5, right? And you'll notice it's a negative, so that means one has to be positive and one has to be negative. Now the cool thing about this is when I do my inside, outside, inside, right? My outside is going to be 2r times minus 5, so I'm going to get negative 10r, and my inside is going to be positive 10r, and those guys are going to cancel each other out to 0r, right? And so you're going to end up with 4r squared minus 25. This is how we would factor the second equation. Any questions? Is this pulling up memories of factoring? You're like, what is she doing? Yeah, it's in there somewhere. All right. Good. I'm glad people remember it. That's good. Okay, so let's do barely. It's in there somewhere, right? Okay, so last up we've got, well, not last in this set, we've got, actually, let's come back to that one if we have time. I want to make sure we get through this other ones. One other method that they've kind of thrown into this section that is completely valid and allowed is one that we're going to use in examples 4 and 5. So if you look at example 4, we have 12x squared minus 4x, if my computer will let me, right, minus 40. Okay. Now, when you go to start thinking, okay, what are the factors of 12x squared and 40? There are a lot of numbers that you could come up with to factor for 12 and 40 and a lot of combinations to kind of think through. One of the things you might not think straight off the bat, but could be really helpful, is to notice that we have our coefficients are 12, 4, and 40. And all of those are factors of 4. So we can actually pull a factor out of all of these to make we can pull the factor of 4 out to make our factoring easier. That's a lot of factoring. So what I mean by that is if we pull a number 4 out of this equation, that's allowed, right? We can do 4, and if you pull 4 out of 12x squared, we can say that's 3x squared minus, and then 4x, and we pulled 4 out, minus x, and then we pull a 4 out of 40, which is going to leave us with 10. Okay, so pulling this 4 out is the same equation. These two equations are still equal to each other. We've just pulled a 4 out of the equation. We're allowed to do that when we're factoring because if you multiply, if you distribute, my favorite property, right? If you distribute the 4 out, you're going to end up with the same equation. But what this does for you is it makes it way easier to figure out how to factor what's left over in here. Because to figure out all the factors of 12, you're going to have like 1 and 12, right? You've got 2 and 6, you've got 3 and 4, and then 40 has all kinds of factors, right? 1 and 40, 2 and 20, 4 and 10. We've got all kinds of factors there. What we've done is we've simplified a little bit, and we're able to have less factors that we have to deal with. For example, 3x squared, the only way to make 3x squared is 3x times x. Okay, and then 10 has a few more factors, but not as many. So we've got 1 times 10, and actually I'm being a little sloppy with my signs. It's actually negative 10. So it's either going to be negative 1 times 10 or 1 times negative 10, negative 2 times 5, or 2 times negative 5. So these are a lot less number combinations to deal with than my original equations just by pulling out the 4. Okay, so now let's say we still keep 4 out front. And now we have to figure out how we can factor 3x squared minus x minus 10. Okay, we know it's going to be 3x and x because that's the only way to make 3x squared. And let's kind of think here. We're trying to get an outside-inside term of negative x. So we kind of want to keep our numbers close together, right? We really don't want to put a 10 right here because 3 times 10 is 30. And there's no way we're going to come up with a really big number. So we're pretty sure that 10's not going to go here. We're probably thinking we want to keep a 1 or a 2 in this position. So, and you can just guess, right? Kind of use your educated guess. I'm going to maybe guess if we put a 2 here, you get 2 times 3x, which will be 6x. And then over here, we can put a 5, which is going to give you 5x. And hopefully those two can cancel each other out. So you might be able to look at this and kind of say, oh, which sign is going to be positive and negative? So let's just say, let's make this positive. If my computer let me. Let's make this positive and this negative. So let's check the inside outside. Outside is going to be 3x times 2, which is 6x. And inside is going to be negative 5 times x, which is minus 5x. And that's going to give me a positive x. So if you end up factoring and you end up like, okay, I've got positive x, but I really need negative x, that means you're super close. And all you need to do is probably switch your signs. So instead of a positive 2, I'm going to make this a positive 5 and a negative 2. So now if I check my inside outside, I get -6 plus positive 5x, and I end up with -x. So that is how I would factor number 4. And this is how you would write it. You would write it 4, right? Because we pulled out the 4, times 3x plus 5 times x minus 2. So that is allowed to pull out a factor if you see that. So any questions about that? Nah, just another way to make it more complicated to factor, right? All right, I was just checking over the next one to make sure that I could do it. I'm doing all these without, for whatever reason, I don't have notes for this, so you guys have to check my work. Okay, so number 5 is kind of going to be a similar thing. We've got -8y squared plus 28y minus 60. 60, there we go. We've got some really big numbers there, so we're going to have to think big factoring numbers unless we can pull something out. And the first thing you say is, can we pull 8 out? Because that would make it super easy. But unfortunately, 28 doesn't divide by 8. We can, however, pull 4 out because 4 goes into 8, 4 goes into 28, and 4 goes into 60. The other thing that you might notice is that out front here, we have a negative in front of the 8. So that kind of adds another twist. We could leave the negative sign in there, or we could say we don't really want to deal with negatives when we're factoring. So we're going to not only pull 4 out, we're going to pull a -4 out of the equation to make our factoring lives easier. So if we pull a -4 out of -8y squared, we're left over with 2y squared. Okay. If we pull a -4 out of 28, we're going to actually get -7y. And if we pull -4 out of -60, we're going to get +15. Okay. So can you see how that flipped all my signs by pulling the negative out? It flipped all 3 signs, which is a good thing because it's actually easier to factor when our first term is positive. So now we can get down to actually factoring what's left over. So 2y, 2y squared, the only way to make 2y squared is going to be 2y times y. 15, we've got a couple options. We've got 1 times 15. We've got 3 times 5. We have -1 times -15. And we have -3 times -5. All right, so let's see. I know it's going to be 2y times y. And now I have to figure out what combination I'm going to put in here to get an outside-inside term of 7. So usually to get an outside-inside term, let's see. Usually you don't want to go with the really big numbers unless you have an outside-inside term that's really big, because dealing with 15 is going to be it's going to be hard to make 15 turn into -7y. So I'm going to guess that we're going to go with one of these two, 3 times 5 or -3 times -5, right? So let's pick one. Let's do 5 and 3. Let's do positive and positive. So if I check that, I get an outside term of 6y and an inside term of 5y. So that's going to give me 11y. So that one fails. So no on positive, positive, right? But I also have to check, remember, I have to check my reverse order. So I can say, I'm writing over top of things, 2y plus 5. I have to check the reverse of that. So if I do my outside inside, I'm going to get 10y plus 6y. So that doesn't work. That fails. All right, so let's try my, well, you know what? Actually, yeah, 16y, that fails. My negative and negative of that are just going to turn everything negative, so that's not going to work. I'm beginning to wonder if this one is not factorable. All right, so let's try 15. I could be wrong. So let's try 2y plus 1. And let's try y plus 5. No, that's not going to work. 15 and 2. So we're going to get an outside inside of 4y plus 15. That's not going to work. I'm beginning to think that this is not factorable beyond this. Does anybody else have an idea for how they could factor this? Am I missing anything? Like I said, I'm doing this without notes, so this is or without a key. Does anybody see anything that I'm missing? Yep. I agree, Greta. I don't think it's factorable either. Actually, technically, we did factor by pulling out a -4, but I don't think we can do any factoring beyond that. Okay. So now we have 2 more examples left to make the page all messy. So this actually, up to this point, we were just factoring. So now we're actually going to use the idea that once we factor, what about number 6 and 2? Oh, Elijah, that's a good question. So when you're factoring, you are looking for, at least right now in algebra, when you're factoring, what you're looking for is whole numbers. Yep. All right, so let's try number 6 and 7. So this is where we actually get to solve. Like the point of factoring is to be able to solve equations. So the first, number 6, is kind of a tricky one. So we've got 14s squared minus 21s equals 0. And what we are trying to do is we're trying to solve for s. So what does s equal? Okay. So this one looks a little weird, right? Most of our quadratics have 3 terms. They have a constant at the end that we have to factor out, but we don't have a last term here. And the reason that I say this is tricky is because we just spent, 35 minutes figuring out how to factor in that particular way. But when we get to this problem, you kind of forget the basics that you learn in Algebra 1. So we have 14s squared minus 21s. The first way to factor something is just to pull something out. That's actually factoring as well. So what I can say is that 14s squared and 21s both have a 7s in common. Oh, Greta almost had it. Yep, 7s. They both have a 7s in common, right? So we can actually pull 7s out of both of these. So if I pull 7s out of 14s squared, I'm left over with 2s. And if I pull 7s out of 21s, I'm left over with -3. equals 0. iPhone 7S, yeah. So that is the kind of the first way that you learn to factor way back in Algebra 1. But once you start getting going on all this fancier type of factoring, then a lot of times, even me, like, well, the first time I looked at this problem, I was like, huh. You can still just pull things out, and that's your first kind of easiest way to factor, and then move on to trying to factor, by unfoiling. Nope, I did not solve it, Elijah. That's right. So now we have to remember my fancy rule, which is something times something equals 0. That means one of the two somethings has to be 0. So that means that either 7s, because that's one of my somethings, 7s has to be equal to 0, or 2s minus 3 has to be equal to 0. So if 7s equals 0, divide both sides by 7, and you get s equals 0. That's one possible answer. Over here, we have 2s minus 3 equals 0. Add 3 to both sides. So we get 2s equals 3, or s equals 3 over 2. So to solve for s, there's going to be two possible solutions. S equals 0, or s equals 3 over 2, or 1.5. So when you have a quadratic, remember the quadratic equation looks like a parabola, right? And what you're trying to figure out, oh, that's not what I was trying to do. It's swiping, that's what it thinks I'm doing. So you have your parabola, right? It's nice and graphed. Nope, that's not going to work the way I drew it. Ignore this line. You have your parabola, you have your x and y axis. What you're trying to figure out is, when does my quadratic equation equal 0? It equals 0 along this x-axis. So you're trying to figure out this point and this point on the equation. So now, because I'm a nice math teacher, I'm going to show you that that also proves true in Desmos. So I think it's important to know that it all kind of goes together. So let me open up Desmos. I'm going to pause my screen real fast, really quickly. That's not what I want. All right, so, oh, sorry guys, technical difficulties. All right, so again, I'm just going to show you that this is actually true. So instead of, our original equation had s in it, but we're going to use x because Desmos doesn't know what s is. So 14x squared minus 21x equals 0. Oh, I shouldn't have even showed you that. Solved it for you, didn't it? So if I say it's equal to y, this is how you would have to do it in a graphing calculator, right? What you're trying to do is, when does this equal 0? So the 2 points that equal 0 are when x equals 0 and when x equals 1.5. Okay, so that's visually, this is the parabola, and you're trying to figure out, when does it equal 0? You get it now? Awesome. I'm not just showing you this to cheat, right? I just want you to know that they all relate together. I think it's actually pretty cool that they all kind of connect together, what you're visually doing. So let's tackle this last one so we can get you on your way. Solve 4s squared minus 20x. That's totally not going to work the way I have it written. If I asked you to solve this, you could just say no. Let's actually change it so that we can solve it. Let's solve 4x squared minus 20x plus 25. Totally not going to work if it's written like that. Okay, so first up, I think, can I pull anything out? I've got 4, 20, and 25. Well, 4 and 20 I could pull out of 4, but you can't pull 4 out of 25. Can't pull 2 out of everything, so I'm pretty much stuck factoring with what I have. But the math geek inside of me is excited because 4 and 25 are both perfect squares, and I get excited when that happens. All right, so let's see if that's going to add up to anything. So to get 4x, we can either do 4x times x. I'm sorry, I keep saying 4x, but basically to get 4x squared, I can either do 4x times x or 2x times 2x, right? And to get 25, I've got several options. I've got 1 times 25. I've got 5 times 5. And then I have the negatives of both of those. So what I'm going to do is I can't pull anything out to factor it, but I can probably factor this. We're hoping so, right? To figure out what equals 0. So anybody have anything particular? I don't actually know what the answer is off the top of my head. So I'm thinking let's do 2x and 2x and 5 just because, sure, why not, right? Do I want to use the positives of my positive factors of 25, or do I want to use the negatives? I want to use the negatives because I have a negative 20x, right? So in order to get a negative 20x in my outside inside, I'm going to have to throw my negative versions into my factoring. Okay, so if I get 2x minus 5 times 2x minus 5, let's check and see if that is the correct factoring. So my outside is going to be negative 10x, and my inside is going to be negative 10x, and that gives me negative 20x. Woohoo! On the first try. So in order to factor 4x squared minus 20x plus 25, I can rewrite that as 2x minus 5 times 2x minus 5. So now, as Elijah says, but you didn't solve it, right? So let's actually solve it. So 2x minus 5 has to equal 0, or 2x minus 5 has to equal 0. These two are the same equations, right? So if we do a little math, add 5 to both sides, we've got 2x equals 5, or x equals 5 over 2. So for this particular case, there's actually only one solution because we ended up with the same factoring, right? So now let's flip over to Desmos, wherever you are, and let's see how this works out. So we've got, whoa, let's turn that whiteboard off. There we go. We've got 4x squared minus 20x plus 25. Okay, so here's my parabola, and I'm trying to figure out when x equals 0, when we have 0, when y equals 0, what is my x? And my x is at 2.5. So you can see we only have one solution because the parabola, the vertex of the parabola, actually hits on the x-axis. So the only solution is 2.5, or 5 divided by 2. So that is factoring fun. Let me look here. I think that is going to be the last of the factoring that we're going to do in here. Yeah, I believe that's going to be the last of the factoring. We're going to learn some other methods for solving quadratic equations, but I think that's going to be it. So fun, I know. I can hear your excitement through the chat. That's what I said with graphing. Well, this is a graph that actually helps you, right? I could have not told you that you can, check on Desmos. All right. Well, that is all I have for today. So if anyone has any questions, I'm happy to stay on. If not, you are welcome to go and have fun doing your math. It's going to be a blast. I know. Best way to start your Friday. Best way to start the weekend, right? The test is due Monday. That is correct, Elijah. Chapter 3 test. All right. Well, you guys have fun. Actually, have a great weekend. I appreciate you guys coming, and we will talk on Monday. Bye, guys.